This lecture is going to be over 25.4. We're looking at the microscope. When we need greater magnification, what we get with the simple magnifier, which is what we talked about in the previous section, the instrument that we're going to use is the microscope, or sometimes called the compound microscope. The essential elements of a microscope are shown here. To analyze this system, we use the principle that an image formed by one optical element, such as a lens or mirror, can serve as the object for the second. In other words, we're changing an image for one, and whatever that produces, we're going to change that using a second element. So we've got our eyepiece, we've got a real image, we've got our objective lens, we've got our object, and then we've got the light source. So what's going on here? Well, we're looking through, and so we're seeing the rays that are coming here, but how are those coming about? So we've got our object, and we've got the eyepiece, or take a look here. The objective forms a real inverted image here inside the focal point, F2 of the eyepiece, which is right here. The eyepiece uses the image as an object and creates an enlarged virtual image. So in other words, we've got our object here, the light comes through, it goes through and then produces the image here. Now, once that's done, the image here, the light goes through that, and then either gets focused here, and then if we take these rays and put them back here at a point where they converge, then we're seeing the virtual image. So the object O to be viewed is placed just beyond the first focal point of the objective, a lens that forms a real enlarged inverted image, which we saw. And then the image lies just inside the first focal point of the eyepiece, also called the ocular, which forms a final virtual image of eye at I prime, which is pretty much what I had just talked through. As for simple magnifier, the most significant quantity for microscope is the angular magnification. The objective forms an enlarged real and inverted image that is viewed through the eyepiece. Thus, the overall angular magnification of the compound microscope is the product of the lateral magnification of the objective and the angular magnification M2 of the eyepiece. First is given by this, where S1 and S prime of 1 are the object and image distances, respectively, for the objective. Ordinarily, the object is very close to the focal point, and the resulting image distance, S prime of 1, is very great in comparison to the focal length of the objective. Thus, S1 is approximately equal to F1, and M1 is somewhat equal to this ratio. So the eyepiece functions as a simple magnifier. Its angular magnification is going to be this, where F sub 2 is the focal length of the eyepiece, considered as a simple lens. The overall magnification of the compound microscope is the product of the two magnifications, so you can see them multiplied there. M1 is going to be the lateral magnification of the objective lens. M2 is going to be the angular magnification of the eyepiece. And microscope manufacturers usually specify the values of M1 and M2 for microscope components rather than the focal length of the objective and eyepiece. So you got some problems there that you can work through.